So I have this function, f of x equals x squared minus 4 over x minus 2, right? That's a function. And I could ask about domain and range, right? Domain is usually relatively easy. Range is usually a little bit harder, sometimes not so bad. So looking at this, I can tell right away, well, if I plug in the number 2, things gonna go sideways, right? If I say, okay, what's f of 2? Well, that's going to be 2 squared minus 4 over 2 minus 2. So I get a 0 over 0, right? And you could say, oh, well, that's 0, right? Yeah, that makes sense. 0 on top, the whole thing's 0. Or you could say, oh, that's 1. A thing divided by itself is always 1, right? Well, this thing is what's called an indeterminate form. So when I lecture, I have a tendency to be a little long-winded, and I spend more time on a particular topic than maybe is necessary. And sometimes sometimes, if we're talking about the concepts central to the course, then no time is wasted, but we still have to cover the topics list, and we have to get through things at a certain pace. So I'm going to try not to be too long-winded, but I want to talk a little bit about what does that mean? What is this 0 over 0 thing? So if I had something like, say, 1 divided by 0, right? In fact, let's back up from there. Let's back up a little further. If I have like 6 divided by 2, right? When you learn division, you learn it in terms of multiplication. And you learn subtraction, you learn it in terms of addition, right? And you learn that 2 plus 3 is 5, and you learn through counting how addition works. And then, a week later or 2 weeks later, or whatever it is, after you've been required to memorize addition tables, you've memorized most of them, at least, well enough to pass a test or something. Then they teach you subtraction, and it's generally framed in terms of reverse addition. What do you 5 minus 3 means what do you add to 3 to get 5, right? And since you've memorized this, you have to think through the list of options. Oh, 2 is what you add with 3 to get 5. And when you learn division, it's framed in terms of reversing multiplication. So 6 over 2 means what do you multiply with 2 in order to get 6, right? And because you've memorized multiplication tables, well, it's 3. So I get 3 this way. So really, I'm saying, oh, this is because 6 equals 2 times 3. I'm doing division by thinking through the reverse of multiplication. This concept of reversing a process is extremely important. This is a theme that shows up over and over and over in calculus, so and algebra really. So try to keep that in mind. We're reversing a process, and that this concept will come up again a little bit later as well. So, well, later in the course. I don't mean later today necessarily. So if I have something like 1 divided by 0, and I say, well, what is that? Is this 1? Let's just say, is this some number n? Is it some number? Well, that's only going to work if 1 equals 0 times that number, right? That's the corresponding multiplication statement, right? And this just does not work. This never works. There's no number that you multiply with 0 to get 1. Not even complex numbers. It just doesn't happen. But if you have something like 0 over 0, you say, oh, well, is this 0? Well, what's the corresponding multiplication statement? And in fact, let's do this. Because I don't want this to be unclear. So I'm going to change the color on the denominator zeros so that their placement is a little bit more clear. So this is going to be 0 equals 0 times 0. Like, oh, yeah, that does work, right? 0 times 0 is 0. Cool. So 0 over 0 is 0, right? Job done. Move along. Well, what if we say, well, is 0 over 0, is this equal to 1? Because that kind of made sense as well. A thing divided by itself is always 1, right? 2 over 2 is 1, 5 over 5 is 1, so 0 over 0 is 1. That makes a certain kind of sense. Well, the corresponding multiplication statement is 0 equals 0 times 1. That does work, but now this is maybe a little confusing. What? Which one is it? Right? Is 0 over 0 0 or is 0 over 0 1? It can't be both because 0 and 1 are different, right? So that's why this is called an indeterminate form, because really, 0 over 0 could be anything, any number, because 0 does equal 0 times any other number. So that's really the conclusion we want, that it really could be anything. So that's why it's called indeterminate. It could be anything, who knows, okay? So if I say, what is f of 2, we don't really get a result. It's nothing. And to some extent, we might be satisfied. Well, 2 is not in the domain of the function. So asking what's f of 2 doesn't really make sense. But we could ask, well, what should it be? What should f of 2 isn't defined. We don't get a number. We get this indeterminate form. We get no result. What should it be is the way I want to frame this. So and I'll put should in quotes. Okay. And I want to sort of explore this by thinking about inputting numbers that are close to 2. What are those outputs like? A table, and I'll copy the function down here so we don't lose track of it. Okay, so a little table. And by the way, we're not going to be doing numerical tables often. I want to start the concept with a numerical table to get the idea. So if I put in like 1, we said 1 was close to 2, right? So if I put in 1 into the function, what do I get? Well, I'll have 1 minus 4 on top and 1 minus 2 on bottom. So I'm gonna get 3, I think, that way, right? You'll have -3 over -1, so 3. Okay. Well, remember, as we said, 1 is not very close. So let's try something closer to 2. How about 1.5? So at this point, I could bring up a calculator. I'm not going to do it just yet. We'll do it with the harder numbers. Let me turn it on first. And also, I can put once. Oh, I'm sorry. Hold on. Yeah. Once I put the calculator on the screen, you'll see what I'm working with here, and on the YouTube stream, it won't show up in Zoom. Although I could adjust that if I really needed to. For this one, this is not too bad. If I put in 1.5, right? So if I have 1.5 squared minus 4 over 1.5 minus 2, so this is 2 1/4. I'm going to erase all this in a minute. I just want to write out the calculation, then I'll erase it. So negative 0.5. So this is negative 1.75 over negative 0.5. Oh, I get 3.5. Okay, so 3.5 is what you get from plugging in 1.5. Okay, get rid of all that. And of course, you could use a calculator. So I just wanted to show that we don't need a calculator for this. It's just faster to use a calculator. What about 1.9? Well, I'm going to do this one by hand again. After that, it's going to start getting a little, a little tedious. So we'll switch to calculator in a minute. So 0.61, I believe, minus 4 over negative 0.1. So this will be, is that right? 3.61. So this is, I feel like I have a mistake somewhere. Maybe I should be using a calculator. So this is negative 0.39 over negative 0.1. So I get 3.9. Okay, so 3.9 is what we get as a result. Okay. But I want to get closer. I want to look for a pattern of behavior. What is the function doing for numbers near 2? Let's try 1.99, and I'll pull up the calculator for this one. So again, this will show up in the YouTube stream, but it will not show up in the Zoom call. So this is an emulator that I got from TI's website, and there's a 90-day free trial. I'm about halfway through it. So if you want to use this, I'll put a if you just send me an email and ask, I can just send you the link, or I can maybe put this the link to this as in the description of the video for people watching later. But if you want to download this, just let me know and I'll send you the link. This is a pretty good calculator. If you don't have a physical calculator, you might want to get an emulator. It's pretty easy to use. Okay, so I want to do parentheses 1.99 squared minus 4 divided by 1.99 minus 2. Okay, and hit enter, and I get 3.99. At this point, you probably are seeing a pattern, right? The bottom row, for every pair of input-output pair, the bottom value is 2 points higher, right? 1 turns into 3, 1.5 turns into 3.5, 1.9 turns into 3.9, and so forth. So if I go into 1.999, I'm expecting to get 3.999. That seems to be the pattern, but I don't want to assume. So I'll type this in again. So 1.999 squared minus 4 divided by 1.999 minus 2. And I'm expecting 3.999. Syntax error. That's not what I expected. Yeah, I have too many parentheses. Okay. 3.999 as predicted. Okay. So yeah. Sorry, I'm struggling with my computer here. For some reason, the mouse cursor. Okay, that's not important. I'll deal with it quietly. So, in this top row, as we get closer and closer to 2, the bottom row gets closer and closer to 4, right? So when you approach 2 from the left-hand side, you're getting outputs that get closer and closer to 4. So the way we'll refer to this is we'll say that the left-hand limit, as x goes to 2 is 4. So we'll say as x goes to 2, and I'll put a little minus sign superscript. It's not an exponent, it's a superscript, so it's in the same position as an exponent. And this is letting me know, oh, we're coming from the negative side of the number line, right? We're approaching on the number line from the left, okay? In fact, let's do it this way. From the left, from where negative infinity is. We never use any negative numbers, but the left-hand side is where negative numbers are, the majority of them at least. So that's how we'll refer to coming from the left. Okay, so as x goes to 2 from the left, y goes to 4. And we won't necessarily always refer to from the left or from the right, or from above or from below. But on a number line, if we wanted to say it, well, y is going to 4 from below, from smaller values approaching to 4, right? We won't typically refer to from which side is y approaching 4. We will typically refer to from which side x is approaching 2. Why is that? Well, with the input, we're actually checking from the left. We're choosing numbers that are to the left of 2, getting closer to 2. But for the outcome, we're just seeing what result there is, and we don't necessarily need to think about which side y is coming from, although sometimes that will happen. I should say, in the web work assignment, a lot of the problems are new. The last time I taught this course was, I think, has it been a whole year? It's been less than a year, I think, since I've taught Cal 1, but it's been a little while, and some of the problems have changed. Other people in the department have written new problems. So I don't know if any of them will need this, but they might. I haven't looked at that yet. And I should say that I will open the first assignment today after class. Okay. Well, we're not quite done here. I need to, and also another way to refer to this, we can say LIM, and below that x goes to 2 from the left. And this statement goes under the LIM, not in front of it, not after it. It goes under it. That's the proper notation. Of f of x equals 4. This statement and this statement essentially say the same thing.